In today's note, we're going to be looking at common factoring. So a couple terms you want to go over again. Expand, when we talk about expand, it means to basically write a product of polynomials as a sum or difference of terms. So this basically means to multiply. And when we talk about factor, factor means to write a sum or difference of terms as a product of polynomials. So this is basically the reverse of what we've been doing or what we've just done. So it's the opposite of expanding. So as an example, if I have 2x times x minus 3 and I want to expand it, I want to basically multiply these two terms together. So when I do that, I have 2x squared minus 6x. So if I was given this 2x squared minus 6x and told to factor it, I would need to turn that back into the two numbers that are being multiplied. So I'm either having an expression where there's multiplying or having an expression where there's addition and subtraction. Another term I want to be aware of is the GCF, or the greatest common factor. And again, we've seen this term before. GCF, or the greatest common factor, is the largest term. So it can be a number or letter or both that can be divided into both terms. So it's the largest term, so basically a largest number or letter or both that can be divided into both terms. So if I look at an example, the greatest common factor of 10 and 25, one way I can figure that out is just by writing out both 10 and 25 and thinking, okay, what numbers multiply to give me 10? If I think of what numbers multiply to give me 10, it's the same thing as thinking about what numbers can be divided into 10. So you have 1 and 10, and you have 2 and 5. I'm going to do the same thing with 25. There's 1 and 25, and then there's 5 and 5. So basically, when you're finding the greatest common factor, you're looking for the largest term that can be divided into them nicely, right? So you're not worried about the decimal numbers or anything like that. So looking at all these numbers that can be divided into both of them, the largest one we see is 5. So that means that the greatest common factor between 10 and 25 is 5. So in the second example, 3x squared and 12x. Here we have to think a little differently because we have a variable as well, or a letter. So I'm going to look at the numbers first. So the only way I can multiply 3 is 1 and 3. And then I have 2 x's to worry about for the x squared. For 12, I have 1 and 12, 2 and 6, 3 and 4, and only 1x to worry about. So going through, I'm looking at two things here. I'm looking for the largest number, which in this case is 3, and I'm also looking at how many variables do I have that are the same, which in this case is just the x. So that means my greatest common factor is 3x. So we're going to look at now, how do we use those greatest common factors to help us factor? Well, let's look at the first example, 4x minus 20. So the first thing I want to do is find the greatest common factor. So what's the largest number that can be divided into both 4 and 20? In this case, it is 4. There's no variable that's shared between them, so it's only going to be a number this time. So the way it works, the first thing you want to do is write the GCF, your greatest common factor. So I'm going to write my greatest common factor. Then, in brackets, you're going to divide the original expression by the GCF. So that means I'm going to take 4x minus 20 and divide it by 4. So 4x divided by 4 is x, minus 20 divided by 4, which is 5. So that is the factored form. I'm going to do the same thing with the next one, 2x squared plus 8x. I'm going to find my greatest common factor. So what's the largest term that can be divided into both? Well, numbers wise, there's only 2, but I do have an x that's shared between them, so I'm going to write 2x. I'm going to then write that greatest common factor on the outside, and inside the brackets, I'm going to divide that original number or original expression by 2x. So 2x squared divided by 2x is x. 8x squared divided by 2x is just, not 8, it's 4. For C, it's the same thing. Greatest common factor in this case is negative 30x, or sorry, negative 3x. 3 is the largest number that's common between both of them, and they do share at least one x. So I'm going to write that greatest common factor on the outside. I am then going to divide the original term by negative 3x, so I'm left with x, and then positive 7. Because negative 3x squared divided by negative 3x is just x, and negative 21x divided by negative 3x is positive 7. For D, D may look more difficult because I have 3 terms, but the only difference is I just have to take each term into account when finding the greatest common factor. All the other steps are the same. So, greatest common factor between all 3 terms is just 6. There's no variable that's shared between all of them, so it's only going to be a number. So I'm going to write my greatest common factor, and then in brackets, I'm going to divide everything in the original one by 6. So I'm going to be left with x squared minus 2x plus 3. And then finally, for the last one, I'm looking for the greatest common factor between all 3 terms. It will be negative 5. The reason I'm taking negative 5 because that's the number or the sign on the x squared value. So I'm looking for that sign as well. So negative 5 is my greatest common factor, and then I'm going to divide every term by negative 5. So I'll be left with x squared minus 5x plus 6. So that is my factored version. In example 2, we're going to basically be doing the opposite of what we've done in the past again, but we're looking at a word problem. So in our previous note, we were given the area or the length and the width and asked to find the area. This time we're given the area and asked to find the length and the width. So we want to come up with expressions for what the length and the width is. So if I know the area is equal to 6x squared plus 20x, so this is basically a sum of polynomial, or a sum of polynomials. I want to turn that into a product. So I want to turn this into multiplying. In order to do that, similar to our last examples, I need to find the greatest common factor. So what's the largest number or term that goes into both of those? The 6x squared and the 20x. So looking at the numbers, just the 6 and the 20, the largest term or the largest number that goes into both is 2. And then there is a shared x value between the both of them. So that means I'm going to write my greatest common factor out, 2x, and then in brackets, I'm going to divide the original by 2x. So I'll be left with 3x plus 10. So that means that my width, you could say, is 2x, and my length is equal to 3x plus 10. Again, it doesn't matter which one is which. In the end, it's the same. You can just rotate that rectangle if you want it. So B, I want to determine the length and the width if x equals 20 or if x equals 10. So what we're doing here is we're subbing in our value for x. So my width is 2x, or 2 times 10. So my width is actually 20 meters. My length, 3x plus 10, or 3 times 10 plus 10, which works out to 40 meters. So those are what my actual length and width are if x equals 10 meters. For C wants to know the perimeter of the building lot. So perimeter, remember, is the distance around an object. So you could think of it as 2 times the length plus 2 times the width. So 2 times 40 plus 2 times 20, we get 80 plus 40, which is 120 meters. So that means that the perimeter around this building lot is 120 meters. So again, the key thing from this note is just to figure out or to learn how to common factor. So you're trying to find the greatest common factor or the greatest term that can be divided into your expression, and then writing that out and then dividing the original expression by that greatest common factor.